Okay, so back to our one proportion z-test. We have checked the conditions. And now we have, that's saying, basically what that's saying is that our sample is reasonably representative to make inference about the entire population of law school applicants. So what we have going on here is now a model with a mean of 63% or 0.63 and a standard deviation of 3.12% or 0.0312, sorry. So that creates a new model to which we are comparing our observed proportion of 163 out of 240, which is an observed proportion of 67.9%. So what we're looking at is, obviously this is a greater proportion than that 63%, but it could just be that it's not big enough to be significant, in that it could just happen because of regular sampling error. So if we end up with a situation where it's so strange that it seems outside of our normal model, then that's what we're gonna come to in determining whether it's statistically significant. So the part that I skipped, which is awesome since I'm, making this video for posterity, should actually go in front of your conditions here, is our hypotheses, and that's the important part of this. So our null hypothesis, that's H sub 0, states that everything is as it's supposed to be. So our proportion that they said at the very beginning, that 63% of all law school applicants were accepted to some law school, that's saying that our overall population proportion of people accepted is 63%. So that's saying that our mean equals 0.63. So this null hypothesis is saying there's nothing strange going on. Everything is the way that it's expected. Our alternative hypothesis is basically saying that this program, the L satisfaction, is making enough of a difference that the people who use that program have a greater proportion, a significantly greater proportion than 0.63. So that's saying that our mean, our mu, is greater than 0.63. So these are the hypotheses that we're testing. One of the things you need to understand is that you're either going to reject the null hypothesis or you're going to fail to reject it. You're never going to accept it because you can't ever prove that the actual proportion is 0.63. You're just going to say you have enough evidence to reject it or you don't have enough evidence to reject it. So we'll get to what those numbers are in a moment. So now that we have our proposed mean and we have our proposed proportion and our observed proportion, shoot, how many times am I going to screw this up? We're not using this as a mean, we are using this as P. So our population proportion. Sorry about that. So we take our observed proportion, and this is our mechanics portion of the hypothesis test. We check the z-score for it. So our observed proportion was 0.679 minus our hypothesized proportion of 0.63, all divided by our standard deviation of 0.0312. So that's the z-score, the observed, minus the mean divided by the standard deviation. That's what we're using here. So 0.679 minus 0.63 divided by 0.0312. I put in the wrong number. 0.049 divided by 0.0312. So we end up with a z-score of 1.5705. We should probably already be pretty aware that that is not going to be an abnormal z-score. That's within 2 standard deviations, so there's probably nothing strange going on here. But we have to get what's called a p-value. And a p-value is we're just going to turn this into a probability. But what the p-value actually is the probability of seeing a result such as this. Huh? Or my husband's making obnoxious comments in the background. So the p-value is the probability of seeing a result like this, that 0.679, given that this null hypothesis is true. So when we turn this into a probability, we use the same notation we've been using, the probability that z, because our alternative hypothesis is greater than, then we're going to say the probability that z is greater than 1.5705. And this is the only notation that we need, but I'm going to write down what you put in the calculator. So that's the normal CDF, and that's going to be 1.5705, comma 99. So second bars, normal CDF, 1.5705, comma 99. And that gives me 0.0581. And that's actually kind of borderline, not super duper borderline, but what we're looking for and our threshold is pretty typically going to be 0.05. And if our p-value is less than 0.05, we're going to reject the null hypothesis. If it's greater than 0.05, we're going to fail to reject the null hypothesis. So this is greater than 0.05. Not by much, but by enough. So we get to the conclusion. And that is based on and I'm calling this a high p-value because it's greater than 0.05. And we'll talk about alpha levels next chapter. You need to make sure you read that because we're not going to be able to spend as much time as I would have liked on it. So based on the high p-value of 0.0581, I fail to reject the null hypothesis. So here's what I mean by that. Oops. I have a greater than 5% chance of getting a result like this, the 0.679, just based on sampling error. So that means I do not have enough evidence to say that this is not true, that the null hypothesis is not true. So I need to follow this up with the context of the problem. So this is always going to be my first sentence in my conclusion. Based on the p-value, I either fail to reject or I reject the null hypothesis. In this case, I failed to reject. So that means there is not enough evidence that the satisfaction program participants have a higher acceptance rate than other law school applicants. Okay, so it is not abnormal for a hypothesis test to take up the entire page. So the necessary parts of this, and this is actually where you want to start, is your hypothesis. This is, God damn it. This is number one right here, your hypotheses. Always has a null hypothesis. Remember, these P's are the population proportion, so no hats on them. That's very, very important. You can get your entire hypothesis section wrong if you don't do that. So the hypotheses, the conditions, that comes next. randomized 10% success failure, and then you need to state the conditions are met and what kind of test you're going to continue with. And this is a one prop Z test because we have one sample that we're comparing against a theoretical value and we're using z-scores for it. And then we come down here, this part right here, that is your calculations, your mechanics is what it calls it in the book, where you calculate the z-score and you get a p-value. Make sure you label what your p-value is and make sure that is clear. And then in your conclusion, you need two parts. So based on the high p-value of 0.0581, I fail to reject the null hypothesis. So the first sentence should always be based on your p-value, what your decision is. And then you follow that up with the context of it. There's not enough evidence that the L satisfaction program participants have a higher acceptance rate than other law school applicants. So because this number was higher than 0.05, then there is not enough evidence because it's likely enough that this could have happened from sampling error. If this was below 0.05, our decision would be to reject the null hypothesis, back up here, in favor of the alternative hypothesis and say that there is evidence that the L satisfaction program yields a higher acceptance rate. But in this case, because it was higher than 0.05, we reject. So that's it for chapter 20. We're going to go over it one day, and we'll spend one day on chapter 21. So please make sure you've read those very, very carefully, especially chapter 21. It's not an easy chapter. And I will see you guys hopefully the day after today or tomorrow. But we'll see. Have a good one.